So before we start, we're going to ask the question. I want us to find the absolute max, which is the absolute highest point on this graph, and the absolute min on this graph. And there are two places where these things can occur. One is it could occur at a critical point, or it could occur at the end point. So I have to check out both the critical points and the end points and figure out which one's going to be the absolute highest and which one's going to be the absolute lowest. So let's start with the critical points, and that means I have to find out where the derivative equals 0 or does not exist, and that means I need to take the derivative. So the derivative is 18 plus 30x minus 12x squared. Actually, before I start, I should always establish what the domain is of the natural domain of the function, and it's all real numbers in this case because it's a polynomial. Just sort of skipped over that point, but it's an important piece of the puzzle, so especially in more complicated functions, which you will see later on. So now I've taken the derivative and I want to figure out where does the derivative not exist. Well, it exists everywhere. This is a parabola, so there's no restriction on the domain. What about where it's equal to 0? So I have to, in order to figure that out algebraically, I'm going to factor. And if I factor, I end up with 3 plus 5x minus 2x squared. And some of you would prefer to have a leading coefficient that's not negative, so I'm going to actually factor out a negative 6 and then put the x squared first. And now I factor. And I do this in my head by trial and error. I say what multiplies to give you 2x squared, 2x and x. What multiplies to give you negative 3, 3 and 1, and then I kind of play with it in my head to figure out where I'm going to put it in, which bracket I'm going to put it in. And that's the solution. You can double check it by multiplying it out. And now I'm figuring out where is it equal to 0. So one place is where 2x plus 1 equals 0, which means x equals negative a half. And the other spot is when x equals 3. So those are my two critical points. Now I have to check that along with my endpoints to figure out what is the absolute lowest. So I'm going to do that by making a small table of values and checking out each of these points. So negative a half I'm going to check out, 3 from here, and the two endpoints. So negative 3 and positive 4. And I'm going to plug these x values here into my original function. So and I've already done this ahead of time, so when x equals negative a half, you get a y value of negative 19 over 4. When x equals 3, you get a y value of 81. When x equals negative 3, you get a y value of 189. And the last one, when x equals 4, you get a value of 56. So looking at these y values, we can establish that this is the absolute lowest one, which means that negative 1/2, negative 19 over 4, is where the absolute min happens. And on the other side, the absolute max, because 189 is definitely bigger than everything else, the max is at negative 3 and the y value is 189. So this is the max and this one's the min. And if you were asked to find out what is exactly the max, you would only answer what the y value is. This gives you both where it happens and how high or low it goes. Now we started with a polynomial and we're going to move on to something that's a bit more complicated. So again, I want to find the absolute max and absolute min. So I'm going to have to find the critical points and I'm going to use the endpoints. Those are my two steps. So critical points. Before I do that, I'm going to figure out the domain. So x cannot equal negative 1 because otherwise you're going to divide by 0. So the natural domain are all real numbers except for that one. So I'm going to take the derivative, and the derivative, I'm going to have to use the quotient rule. So the derivative of the top times the bottom minus the top times the derivative of the bottom divided by the bottom squared. And if I simplify this numerator, the x's will cancel and I'll end up with 1 over x plus 1 squared. So I'm looking for critical points. Where is it the derivative equal to 0? Well, you can only get a derivative equal to 0 if the numerator is equal to 0, and that's not going to happen. What about where the derivative does not exist? Well, you might say, hey, the derivative doesn't exist at -1. But it's not a critical point because the function isn't defined at -1. So there are actually no critical points. That means I am left with checking out the endpoints. So I'm going to check out 1 and 2. When x equals 1, I get 1/2, and when x equals 2, I get 2/3. So this is my absolute min, because it's the lowest y value, and this is my absolute max, because it's my highest y value. And I'm not putting these on there because they don't exist. So we're going to do one last example, this time diving into the realm of logs. So I, again, am going to take the derivative of this, the derivative of the top, times the bottom, minus the top, times the derivative of the bottom divided by the bottom squared. And this cancels here, so that leaves me with 1 minus natural log of x over x squared. And I keep forgetting to figure out what the domain is. So the domain here is you can't divide by 0, so x can't be 0. But more specifically, you can't take the log of a negative number. So that means x has to be greater than 0. That's the natural domain of this function. And I'm not going to consider anything that's not greater than 0. So my next question is, I want to find the critical points. So the critical points are where the derivative equals 0. So that means where the numerator is 0. So 1 minus log x equals 0. So that means that 1 equals log x, and writing that as an exponent because the base is e, this means e to the 1 equals x, or e equals x. So this is a critical point because it's where the derivative is 0. Where does the derivative not exist? Well, it doesn't exist when x equals 0 because you're going to divide by 0, but that's not in the domain anyways. And it doesn't exist actually when the log of a negative number, but that's not in the domain. So there is no place in the domain that the derivative doesn't exist. That means I've only got 3 points to check out on my scale. The first is the critical point when x equals e. Then I've got when x equals 1 and 3 because those are my 2 endpoints. And if I plug in x equals 1, sorry, let's start with x equals e. I get the natural log of e over e, and natural log of e is 1, so this reduces to 1 over e. When I try plugging in natural log of 1 over 1, natural log of 1 is 0, so 0 over 1 equals 0. And the last one is the natural log of 3 over 3, and if I want to compare these, it might be easier to look at it as decimals. So putting this into the calculator, let me do that for a second there, and I get 0.366 approximately. And when I put 1 over e in the calculator, I get 0.368. So they're very close, but one of them is definitely bigger than the other. So this is my maximum, and this is my minimum because it's definitely the lowest. So if I ask what is my maximum value is 3.368 approximately, or I should probably write it as 1 over e. My minimum value is 0. 0. And that gives you a little bit of a snapshot on how to find absolute maxes and absolute